Hello, and welcome to our next workflow demonstration. This time we have this front bumper insert slash fog light trim or bezel, call it whatever you want. We have received this scan data from one of our users, and he was slightly struggling to recreate all this geometry here. And that's why we're going to take another shot and create another workflow demonstration to see how you can handle such parts. As a first here, of course, I'm going to align this somehow to coordinate system, at least roughly, or actually it looks like quite planar parts, so probably we can actually align this really close to coordinate system, and that will make our life much easier designing down the road. So actually here we can see that it has some really slight curvature here, but it's like 0 point couple millimeters. So most likely this is just a deformation because this part is like used part and have been installed in bumper, living in the sun and so on. So in this case, like 99.5% this was designed as a flat, and that's why I'm going to actually also design this as a flat surface here. And next step for alignment here would be, I think I will just create here one 2D sketch just to get this honeycomb pattern, and I'm going to fit one entity somewhere here to, okay, actually it's slightly different, so I'm going to fit one entity at the edge of one of these honeycombs like this. Okay, and actually probably I can create another cross section somewhere here, and I will fit a circle here around where originally fog light is coming through. Okay, so here we can see it's not actually a complete circle, it's more or less like a slight ellipse or something. But in case where I just need this geometry to align my scan to coordinate system, this will work absolutely fine for my case. Okay, so we can go now to align by coordinate system. Let's select plane as a primary feature. Probably I will say it's a front plane, and I guess I want to flip it. Secondary, probably this line. A tertiary point now, actually wrong here. So as a secondary, I want to pick this point, and the third entity will be my line that will define direction. So let's hit and apply. Let's enable isometric view. Okay, so here we can see that I have wrong orientation right now. So I'm just going to flip direction of plane and hit apply once again. Okay, so I'm here. To be honest, I have no idea if this is the correct orientation or it should be like upside down, but for purpose of reverse engineering, this actually doesn't matter. Okay, so we have to start here with something. We have, let's say, one plane. And as a next step, I think I would just start with going around and creating all this frame here. And of course, this part is not like completely disassembled. You can see it's actually assembly of two parts, and that will make our workflow a little bit more complicated, but nothing too serious, I guess. So it's a good question if to model this as a one complete solid or try to recreate this as a two separate parts. Probably I will try to do this as two separate parts and see how it goes. As the first thing here, I think I'm going to focus on the outside surface here. And of course, as always, we have many different options how to recreate the surface. So if we're looking closer at the surface, so we can see it's not completely straight extrusion. And you can see this side is more or less in one direction, this bends slightly outward. The third surface is completely different. So we have options. Let's say, first of all, we can create a 3D sketch here. Not 3D sketch, but 2D sketch by slicing our scan data to get a complete outline of this. And for example, we can start by fitting a couple entities and try to actually extrude them to see how it goes. At this point, I'm going to enable analysis for entities to see how close I am here. And once I have fitted this one, so let's try to do an extrusion here to see if it's any good. Okay, let's try to apply draft right now with deviation analysis enabled. So we can see it's sort of good and not that perfect at the same moment. So we have to figure out, are we going to keep this result or we're going to change our plans and work this part around a different way. And we have to understand how close we want it to be to our initial scan data, of course. So this would be like a first example. We can create entities all around, extend them, then intersect, trim, add fillets or blends. Another option, of course, we can recreate all this with use of new freeform. So let's fit freeform. Let's subdivide it a couple times. Okay, so we're super great at deviation here at the moment. And of course we could go patch by patch all around this part, or probably it would be more advanced way just to simply extend this surface, say in all directions, so it completely goes through all my scan data. Okay, let's accept this one. After that we can create another one on this side, and the same way we can subdivide it, slightly reposition our vertices here to get closer to deviation. Okay, something like this. Again, we can come over, extend it in all directions. After that, we can simply select these two and trim to obtain a single surface. And later to come over to add, let's say, fillet here. So we can see fillet is not that perfect at the moment. At this moment, we can actually start to play around with some fillet options. So basically, this is ratio of your fillet. So in more simple language means this center point of intersection we're trying to move to one or to another side. By this we are changing how this fillet overall takes shape. So as you can see here, we can play around quite a lot with it and get pretty much close to actual deviation here. So this is another option how we can do that. And if we're going this way, simply we have individual surface patches here, and probably we can reuse them later to build up this surface of this separate part here. Of course, it's completely up to you, and every different case might need different approach to how recreate surfaces depending on geometry or some issues or something. And as third one I would like to mention is we can create a 3D sketch here. So let's say by starting somewhere here, I can go just all around, snapping my 3D curve points somewhere close to the edge of this part. Simply by going all around here, we create this nice 3D curve. At this point, we don't have to be like super precise, because anyway, we're going to enable deviation analysis to see how close we are to actual scan data. Rotate it slightly to get somewhere closer or further away, or to make it slightly smoother. By positioning our points, we can get, for example, closer to the edge or further away of it, just to make it nice and smooth all around. Okay, so for example, like this. After that, I can come over and create another one. In perfect case scenario, it would be much more easier for software and overall working down the road if these curves would have equal amount of vertices. But it's not a must. Simply, if we don't have same amount of vertices, it might start to twist somewhere and to create undesired results. But in these cases also we can create additional guide curves to compensate this and to get rid of unwanted results. Okay, so something like this. Again, I can come over to reposition my point slightly. So here I can see I have some larger deviation, but this region here looks like filled with 3D scanning software. So most likely the scan data wasn't sufficient here to create a complete mesh model. By simpler words, there was code. Okay, like this. So we can take a look if it's nice and smooth, doesn't have any bumps or jumps here and there. Once we're satisfied with these 3D curves, we can accept them and go to our loft window, select both of them. Let's see analysis. Okay, so we're pretty close. Probably we want to make some adjustments in some places here to make everything nice and green. In order to do that, again, we're going back to edit our 3D sketch. And of course, we can reposition some points here and there, or introduce new extra points. For the beginning, I would suggest you to play around with existing points to have a nicer and smoother surface overall. Because the more points we have, the more these 3D curves will adapt to your scan data, and sometimes that's not what we want. Basically, we want to use least possible points, amount of points that we can manage to produce good deviation, and that will give us the most smooth result possible. So let's see again. Okay, so this time we're within green nearly everywhere, just some small patches here. And of course I can accept this, or at the same moment I can try to expand this loft. And just above or below my scan data, so it intersects completely. Okay, so I'm going to accept this one. As next step, I think I will simply thicken this, or at least I will try to do that and see how it goes. Basically, this way I will try to reconstruct thickness of this frame. Okay, so it's something around 2.3 millimeters thick wall. At this point I can accept this. Okay, good. I'm pretty much satisfied with this result. So the last thing for this frame here, I would need to add this extra boundary around it. And in order to do that, I have to, well, actually I can do that in several ways, but I will just try to do this the most simple way. I will try to create another plane. Okay, we'll disable locking, and I will try to pull it up to see if we are any good. So at this moment, you can see my plane is quite close on these corners, a little bit further away on the opposite ones. So let's say currently this is something like super average. So we're at 0.3 away on these blue corners and like 0.1, 0.2 on the yellow ones. So again, we have to figure out if this is a correct solution. Are we taking in account this possible twisting of this part or no? And based on that, we can try to move forward by creating new surface or using this plane that I have just created. So probably we can hide this one for now, and let's see how well was fitting my first plane. So also we had in two corners deviation in one direction, on another two corners in opposite direction. So probably I can simply use the plane I just created here. And consider this to be a good result. So what would be my next step? I would actually cut this solid with plane at the moment. So, okay. Or maybe not yet completely. Actually, we can try to go this way. So again, several different options how we can create this extra edge on frame. We can try to create plane along path, just somewhere where we can see some nice geometry that we want to replicate. For example, let's say here, let's create a cross section here. And in this case, it would be, say we can fit entity here as well. Let's intersect them. Probably add automatic fillet. After that, I want to copy this edge here, just extend it, intersect, and let's just close. Okay, so I don't need it this far. Now let's close our profile. Okay, like this, and now we can actually try to use sweep here. So let's select sketch as a profile and this edge as a path. We can enable deviation analysis to see how close or far we are. So we're actually pretty much close here. So we can simply accept this one and combine all this together to have more or less already a complete frame. Another option is actually to, let's say, create another plane. Pull it up somewhere up to where we can see nice and clean edge, for example, here. Let's accept this plane. At this moment, I will just hide my scan data for better visibility. So I can select all of this, go into trimming. What I want here, I want to uncheck this merge faces command. Get rid of my plane completely. And this result gives me extra face here. Okay, it automatically gives me extra face on inside surface as well, of course. But let's see, this is just an example how we can proceed. I can select this face, go to CAD, oh, not delete faces, but move face command, go to offset, and try to play with it this way. We can enable deviation analysis and see how far we want to offset this to match our scan data. So it's approximately 1 millimeter. In some cases, maybe it's slightly different, but again, it's a good question if we want to go super precise everywhere around or just use one average distance all around this part to make it consistent, let's say so. So these are like two different approaches. Of course, in this case, we don't have the same result as we had it with sweep, because sweep already had angle of this profile here. So our results are quite different in this case. But again, depending on what kind of parts we are working on, how much information do we have, we can use both of these cases. At this point, I think I'm just going to go with this web surface, not surface, but solid. So I'm going to combine these both together and say that my frame is done at the moment. So now I'm going to hide it, and next I'm going to work on the front face of this insert. And again, here we have many different ways how to achieve the same result. We can basically thicken this plane, say we can go somewhere halfway. After that we can create another cross section to create sketch and extrude it further, just this mesh grill here. Or we can go higher up, say for example like this, to create one super thick part, then create cross section and create solid bodies that we will use as a cutters here. And I think this is approach that I'm going to use, not to create like super overcomplicated sketches with a lot of different entities. So I'm going to thicken this plane up to, let's say, maybe 4.5 millimeters. So I catch completely these two corners. These are slightly off, or of course we can go somewhere average. So we have something similar result as we have on our this boundary solid, the frame. So let's hit accept for this. At this moment I'm just going to hide this, and I will create another 2D sketch. Pull it somewhere, I don't know, let's say here, just somewhere where I see good enough results to create proper cross-section sketch. Okay, let's accept this one. So first thing, what I need now, I need to fit a couple entities to recreate this honeycomb pattern. Okay, so it tries to fit circle or arc. So let's just go into more manual brushing and say that I want to fit only lines everywhere. So at this point we can click this option, auto join, so it will intersect all of our entities. Of course we can come over and add fillets here. Say here I want also it to be 1.5, same as on the opposite side, probably these around 2.5. Of course these dimensions right here might be like completely wrong at this moment. As you can see, we're jumping away somewhere. Probably just because this is actually I will start extrusion and we'll try to explain it at that moment. So first of all, direction of this extrusion, and secondary, probably we have some draft here. So if we imagine how this part was created, most likely this is some sort of injection molding, so there must be some draft in order to take this part out of the mold. And of course at this moment we can see here some slight deviation in one direction and opposite side slightly in different direction. So basically this extrusion should be slightly tilted. Of course we can create some reference lines as vectors for this extrusion to get it closer on these edges. Or we can again go simply like perpendicularly to plane that we first created, because we have to remember that probably we have some warping on this part, and this might affect actual geometry on this scan data. So this is something worth to remember. And I will go with just straight one, perpendicular to plane. I'm going to snap the bottom side of this extrusion directly to mesh. So this will be something like this. I'll accept this result for now. So what would I want to do now? I want to add extra fillet here on the bottom. Let's see, this is something around probably 0.5 or 0.6 millimeters. So I will keep it at 0.5. Okay, so basically we have created our first cutter here, and what we need to do now, we need to pattern it. Of course, we could do that in Sketch, but imagine after we would have extruded all of them, we would have to add this fillet individually on each of them. So this would be much more time, much more work to do that, to select all these edges. Instead of that, I will try to pattern this as a solid. So let's select this one, go to CAD, linear pattern. So at this moment I can try just to pull it away into one or another direction, enable analysis, so I can see actually how close I am somewhere. Approximately, let's say this would be spacing of 35 millimeters. I could pattern this, but the problem starts here that I will need to pattern it again diagonally and then pattern it again vertically, because I have quite a lot of entities here, and if we take a closer look, it's not like a completely vertical pattern here, so it's slightly at an angle. For example, if we try to align it to some vertical line here on our screen, we can see that it's going slightly sideways. So this won't work for us. And actually the same happens with these horizontal lines. So we're slightly off. Well, maybe it's like super tiny, but still. So in order to compensate all this and make my life easier, I'm going to duplicate this last sketch I used here. I'll hide my solid for now, and I will go to edit my sketch. So at this point I want to get rid of all these fillets here. Say intersect all this. Okay. And after that I want to say find some good quality scan data somewhere further away from this hexagon there. And let's say, for example, I can try to use this one. What I need here, I need, say, these three lines. Okay, let's intersect this one and this one. And I'm going to create another line from center point of this entity to center point of this entity. And this is going to work for me as a vector for patterning. Okay, let's click apply and hide our solid. Let's go to linear pattern. So here I'm going to use pick option and pick this construction line to define direction of patterning. And of course, at this point, again, I can simply drag it away to see distance of instances. So it's like 19 point something millimeters. Of course, I can make it like simple 19, but at this moment I can actually see that it goes somewhere away from my scan data and deviation is not that good anymore. So let's get it back where it used to be. Okay, so something, let's say this is 19.3 millimeters. And of course I want to add there another one at the very end, and I want to create pattern in opposite direction as well, the same 19.3, like this. One more. So basically, why do I need this one more? Because I'm just going to pattern all this line of solids based on another sketch in opposite direction to get complete grid of these cutters. Okay, so let's accept this one. I'm going to hide all of these solids. At this moment I can come over to the sketch again, and I want to create let's say I'm going to add another entity here, intersect these two, and I'm going to repeat the same operation on this side to create direction vector for patterning. Okay, this way. At this moment I'm going to unhide all my solids, select them, say I want to do linear pattern, direction, select this line. Let's enable analysis. So with bigger count of instances, this patterning might get quite slower, especially if we're using deviation analyzer enabled, because we have quite a lot of geometries to calculate our color plot for preview here. So let's add one more row. I'm just going to disable analysis for now so it runs smoother any direction too. Let's pick the same line, flip direction, so let's say 12.85 millimeters. Let's enable, let's enter the same value here, like this. Okay, and 3, 4, 5, 6, 7. Okay, perfect. So now we can hide the sketch. We won't need this anymore. Now I'm going to, I think, hide my scan data, bring back my thickened plane, and say I want to cut from selected solid. And as a cutter, I'm going to select these patterned solids. So in general, we can see we have 90 of them. And imagine if you would have to add this bottom fillet for each one. So let's click it. We see result. Let's accept this. We can unhide our scan data and see how it looks like. Okay, very well. So here we can see we have really stable deviation analysis around this cutout for fog light. So more or less it slightly warped somewhere inside. And we have the same on the bottom surface and on top surface in each of these corners as well. So this means we're pretty much close to, let's say, design intent of this part. And as next step, I want to bring back my frame solid. I'll hide my scan data for now. And here I can see that, actually I will just pull it back for a second. So previously I created this plane on the backside of my scan data, so I assume this aligns good enough for me. After that I created this frame around a little bit taller than I need, so it intersects completely my plane here. And at this moment I'm going to simply use solid trim function, and we'll get rid of excess of this plane, same as excess of this frame, like this. So we have single solid. Let's click OK. And voila, we have the main body created here. Looks really nice. I like it. So let's bring back our scan data and see what do we need next. So of course, next feature, I think I'm going to just create this hole to have better visibility at how far I am in this project, so it looks more finished, let's say so. And to create this cutout, I'll create another cross-section sketch, lay and this cutout here somewhere. I'll just hide my solid for better visibility. Okay, so this looks good enough for me. Of course, here I can fit some circle, but if you remember from the very beginning of this video, this cutout isn't circular, so it's some sort of slightly elliptic or something. And of course we can try to fit here some arcs to merge all this together into some sort of ellipse. Or probably we can go and say I want to fit here a curve. Select all of these slice points. Oops. Select all of these slice points like this. Okay, so we have this curve here. Probably I want to build it with less points, let's say 10 of them. Okay, this looks good enough. Now I'm just going to merge these together, reposition a couple more points here and there to get closer to my deviation here. Okay, so probably this one as well somewhere, just slightly. Okay, so it looks like I would need to insert here another point. To reach better deviation. Okay, so of course we can sit and play here for a longer time, but well, this is just going to work perfectly for this case. So now hit and extrude. Let's extend it in both directions. Here we can see the deviation analysis. So again, probably the extrusion direction should be slightly sideways, considering deviation tolerance on this side and this side. But for this purpose, I'm just going to leave it as it is. I'm going to unhide my solid and say I want to cut it with extruded solid. Okay, like this. So we have done most part of main part of this assembly here, and the last two tabs I still have to recreate here. So as we can see, actually this one is broken. And in this case, more or less I have just one edge that looks more or less correct. Of course, I can guarantee it's like perfect. But well, we are working with the data that we have here. And this is something that we have to understand. If there is some damage to part you have scanned, then you have to recreate. Just pay some attention. Probably you can spot is this broken part warped somewhere or not, or if it's looking straight. Just simply in real life it's way easier to understand how this part is broken and some direction where it might be bent or something. So anyway, here I can clearly see it's not perpendicular to my first created plane, so I need to get actually this vector here. And in order to do that, I will try to fit a couple planes here. Considering I see this corner is going down somewhere. It's just a little bit more complicated, so probably this part should be as a correct direction, or maybe not really. Well, anyway, since I don't have like a complete information about this, I'm going to use this corner, which one looks more or less intact. And I'm going to create direction vectors based on this, or another option. Probably I can try to use this one to create references and then to compare with another one and see if they are facing the same direction. Of course, here it's not like super great amount of geometry that we could use, but probably we can try to use this part of surface here to fit plane here. Okay, let's create this one. Let's select it and say I want to construct plane from selected CAD face. At this moment I will hide the initial one. I'll make it larger. So here we can see that actually they're quite different, so this approach won't work and I will have to work individually on each of them. And since I have fitted my first plane here, I'm just going to go with this one. So let's create a cross-section sketch somewhere around this region. And let's go and select these three edges here. Say I want rectangle here. Back, let's connect these two, pull it slightly to get closer to slice points, and hit an extrude. So I'm going to snap top part to my plane, and well, bottom part to my solid, like this. But considering we have some empty cavity here, I'm not going to merge all this together. what will create this as a individual solid. Oh, okay, so here I can see I haven't actually snapped to my plane the top part. Okay, let's do it like this. This moment I'm going to hide the plane, hide my scan data. So here I know that I need to recreate this groove at least. Before that, probably I want to add 2 chamfers here. Okay, so let's say 1.2 millimeters. Seems that one side is bigger than the other one, but I'm just going to save my time and work on from here. After that, let's use this planar surface in order to create another cross-section sketch. Okay, so here I want to fit straight line over here. And probably somewhere here. Let's intersect them, extend, hit and extrude. I will hide this solid for now so I can clearly see deviation here. Okay, so it looks pretty good. Probably I can try to change slightly direction of this extrusion, but in case of this part, this is not that super important, so I think I'm just going to leave this right now. And yeah. But before trimming something out, so I can see this tab probably is like a one single feature here. So basically it's not like a different part fitted onto this plastic, but it's also injection molding and what was made all together. And in order to recreate that one, let's see, I will use this plane to create another cross-section sketch. Let's go somewhere in the middle of it. Hit create. And here again, I need to recreate this weird shape, probably to save some time. I can go and ask software to fit here curve. Let's do the same on the opposite side. Another curve. Okay, back. Let's see if we can. Okay, this is slightly wrong. Let's reposition this one as well. It's something like this. And just a tiny bit reposition of this one. Okay. Here as well, I want to snap it on 2 points. Okay, let's make it something like that. And after that, I can come over and extrapolate these curves to intersect them. Extrapolate in this direction. So I have complete intersection with my solid. So let's trim these endpoints. Okay, it's not that simple. So what we can do here, probably we can just create here a line that will allow us to trim our curves. Let's close this one, hit and extrude, see how it looks like. Not that bad, we have some slight deviation. Probably we can try to play around with draft angle to get it slightly closer. So let's snap this side here. Okay, so we don't see actual deviation right now on the top and bottom surface, and most likely that indicates we're extruding a surface right now, and probably there is some reason for that. So most likely we don't have closed profile somewhere. Okay, so here was some issue with automatic snapping. Probably at this point I want to add some corrections to my curves here, because during trimming to rebuild them slightly. Okay, like this. Let's hit extrude once again. Snap this side. Let's snap other side. Let's say I want some draft of 3 degrees. Looks good. Oh, at this point I can actually say combine. This one block on the bottom. Let's hide it. And at this point, well, probably I can create here a cutout, but to be honest, I don't have too much information here. So the backside anyway would be some sort of eyeballing. Or optionally, we can try to use this plane to create another cross-section sketch here to find some sort of information. And at this point, you can try to fit here some sort of line. Well, in this case, we have so bad information, scan data there, so it's like way away from actual scan data. And in order to recreate the same on the opposite side, can actually convert this edge to line. Let's create here middle line. Say this is for construction, this one as well. I'm going to select this entity, construction line, and say mirror. So both of them are at the same angle. After that, I'm going to create here one line. And well, on this side, it's super approximate. But probably I will just connect these two. So it's some sort of perpendicular. Let's say like this. Let's intersect. Okay, it's much more complicated when it's mirrored. So let's create an underline here and just pull this one out of our solid. Okay, let's disable clipping. Okay, should work just fine. Now at this point I can extrude it. Up to, somewhere here. This is best what I can see based on this scan data. Okay, so bottom side cuts it completely, and we can say cut. Okay, good. So we have recreated this feature. I'm just going to hide it for now, so I can focus on this one right here. So again, here, still I have to figure out some directions where it should be pointed. But since I don't have too much data here, we have to figure out some solution, and I'm going to go to extract primitives, use brush tool to use some polygons here in this corner and in this corner to fit plane here. Okay, so my plane, first one would look like this. Let's create this one, and I want to create another plane based on, probably I can use segmentation tool here and use all of these polygons here to fit another plane. Okay, let's create this one. Select both of them and go to construct reference line. So let's hide these two planes. Let's get back a reference line, and essentially I'm going to use this reference line to create plane along path. Okay, since this is a construction line, by the way, it doesn't want to work, but I can go just to 2D sketch, click on pick. Let's say I want it to be somewhere here. So this gives me a nice cross section for fitting entities. So let's select again all of these slice points. Say I want to fit here rectangle. Now let's close it off. Pull slightly out. So here again we have to figure out how far should it be. Oh, I guess I'm just going to use it like this. Okay, based on deviation analysis, we can see the bottom part is slightly out deviation, but only this side, the root where it was broken, still is fine. So that means we're quite good to go. And the top part I'm going to snap somewhere here on the mesh. Okay, like this. So I won't need my reference line anymore. What I need now, I need to create another cross section here to create this tab. Maybe somewhere slightly back so I have better scan data. Just to make the process quicker, I'm going to go the same way as previously. Fit curve on one side, fit curve on another side. Okay, let's extend these two curves. Like this, then I'm just going to add here a line that I will use for trimming these two. After that, I want slightly to reposition all of these curve points here to get closer to my deviation, but actually I still need to extend other side of these curves. And now I can actually come over to play around these curve points here. So let's insert another one. Okay, something close to this. Yeah, again, I have to consider what to do with all of this mess. Do I want to try to get closer to this blend here, or to have it similar as it's on other side? So in this case, I think I will just go quite similar on both sides to have slightly more sharp edge. So again, here we see that our sketch doesn't get a solid color, but let's try to extrude this. Okay. Okay, so extrude, snap to one side, well, snap to another side. Add draft. I had 3 degrees on previous tab, so let's go with the same. What I want to combine. Okay, so let's hide this one. And repeat the same operation as on the other side. Let's find some region with nice amount of information so we can work with something. Let's say, for example, here. I'm going to use these points. Actually, no. So in this case, let's go absolutely the same way as it was on the opposite side. Let's convert this edge to a line. Let's create construction geometry for mirroring. Select this line, construction line, mirror. Let's close one side. Let's close another side. So here we have some information to align it to. Good. Let's just extend it further on the front side. Of course, here we can see that one side is thicker than another side. And probably we want to move it slightly, but still it's quite complicated. This side, as we know, was broken. And it's slightly pointless to align to it, so this is some sort of guessing game at the moment. But okay, so let's make an extrude. I'm going to snap it somewhere, probably there. Let's hide my scan data and hide solid. Well, let's cut through all of it like this. Okay, so I have 2 tabs and my main solid here, and at this moment I can simply go and combine all this into one like this. Okay, perfect. So the next step would be just to recreate this separate part on this side. And of course, as always, we have a lot of different options how we can do that. But before doing that, I just noticed that I actually failed here slightly. So I extruded this block slightly too far. The small one I snapped onto the surface. And this one I simply extruded through all. So let's try to repair this problem here. So probably this was okay. So it's slightly more complicated. Let's just get rid of combine. Well, we have 2 options right now. We can edit extrusion height and snap it to surface here. But at this moment, I had some failing. Another feature that we had to repair, another option was to simply do a solid trim to get the same result. Okay, so at this point we can start to build main surface of this second part here. Okay, so here at the bottom we see it's perfectly the same smooth. It has some creases here, and of course that's something that we will want to consider Do we need them or not? How necessary it is to recreate these creases here? Probably some fitment, or considering that here is some part number doubt it's used for fitment. But this time I think I will go just a simpler. And I'll recreate this as a uniform thickness. So let's hide all the solids and let's get back to it. So basically, of course, we can try to use edge of this solid to start to create it to blend, but normally, since these are two separate parts, there is some tiny gap in between them. So simply I'm not going to copy some edges and try to loft from them. What I'm going to do, I will try to recreate this with new freeform. Most likely the fastest way, or another option, we can try to fit surface here. Maybe it will work. So let's try to get rid of this indent in the middle. Something like this, but we have quite fractured data here. But we can take a look at the result. Not that bad, to be honest. Probably we can live with this result. Or if we don't want this result, we can try to use new freeform as I was planning to do it at the beginning. So let's fit it, I don't know, roughly something like this. Let's subdivide a couple times, snap to correct places on our mesh. And of course it's curving in another direction as well, so let's split it along the long edge as well. Okay, something like this. At this point I can consider to start moving edges here and there. Or individual vertices to get closer. So something like this. Maybe slightly back on this edge. Okay, probably something like that. Yes, we can subdivide this quite a lot. But we have to remember that we want to recreate this smooth as possible, so least possible quad count is what we're looking at here to achieve smoothest surface. Okay, let's say it's something like this. Maybe let's reposition these two slightly as well. Maybe this one. Okay, in general like this. So what next? I'm just going to use extrapolate tool here to create another line. Disable snapping, probably local. Let's try and see No, I don't like this result. Actually, I can simply select these two vertices here and say I want to snap them onto scan data like this. Okay, probably some reposition of these here as well. Maybe this one I'm going to edit individually with disabled snapping just to pull it slightly up, this slightly down. So it's something close to such result. First here we can play quite long until we get like super nice as we want it to be. But let's make it slightly quicker and shorter. Let's extend it one more time. Again, I'm going to edit individual vertices here. This and probably this one as well. Okay, good. So I want to snap this one back. Oh, here I can see some slight deviation. So probably I would have to reposition here some points as well to get really close. But in general, I think this should work good enough. So what I need now, I want to extend this surface to backside, probably to this side, this one as well. Once again, I can still come over to do some adjustments. To get closer to my desired deviation here. So on this side, I think I will just use smooth brush to make it slightly smoother. Yeah, something like this. Okay, so this looks good enough. Let's hide this surface for now. Or actually, I will duplicate this one and we'll thicken this duplicated freeform surface to see how it looks on the bottom side. Okay, so here we can see some deviation on the bottom side. Of course, if we want to get like really super close to everything, we can simply offset freeform surface and reposition snap points back onto scan data on this backside. Or we can go with average thicken functionality to save us some time. Okay, so this one is thickened. What we need now, actually now we need to recreate these side cutting surfaces all around this part. And in order to do that, almost likely I will want to use 3D curve. Just going to snap it somewhere along this edge here, probably somewhere up to this point, because here we have some sharper crease. Probably this is joint for molds. So let's position my spline points. Okay, so somewhere here, let's add another one. Pull this one slightly away from edge. Position this slightly, this one as well. Okay, good. But now I actually will create plane along path. Let's select this path and create a question where I want to create it. Maybe I will start at the very beginning of it. Let's enable clipping so I can actually see what's going on. And as we can see around this edge, we have some bulge on our scan data, and we have to figure out, is this as a design intent or this is a just defect of scan data. So once we have created profile, let's go to sweep, select profile, select path. Let's enable deviation analysis. So here we can see that we are nicely aligning the scan data, and this bulge most likely is a defect. We're not that super great on this side, so we can try to play around with twisting value here to get closer on this side as well. Well, maybe something like this would work absolutely fine. Let's just flip it. Not actually to extend it on this side. Oh, I don't need all. I need just this one edge like this. Okay, so what's happening here? All right, slightly more complicated. And I will have to do some blending there to match all of this. Somehow before I'm doing that, I'm just going to complete the same operation on the other side. So let's go 3D sketch. Here we can go a little bit easier. So let's say something like this. Construct plane along path. Create this in the middle of this curve. Let's create cross section. With another entity here. Like this. Let's just extend it so it intersects completely our solid. Okay, good. At this moment I can hide plane. Let's create another sweep here. See analysis. Okay, fits absolutely great. So now at this point, I can proceed to front edge here. So I'm just going to create another sweep 3D curve. Say something like this. Not to go over this corner. This corner I'll have to recreate a different way. So currently I'm focusing on, say, main surfaces. And deviation control shows it's Good enough. So let's accept this one. Let's create another plane along path here. So let's say here, let's create another cross-section sketch. Again, profile here. Extend it. Okay, let's hide plane. Another sweep. Let's take a look how it fits. Looks good, except of this small bulge here, but most likely this bulge is some sort of scanning defect. Okay, we can accept that. Oh, once we are here, let's see what we can do on this side. So basically, I will create another 3D curve here. Something like this. Fits well, it's smooth enough. Let's accept this one. Create another plane along path. Probably I can create it somewhere here. Let's go another cross section. Let's fit another entity here. Okay. And repeat sweep operation. Okay, this looks good enough. Okay, so this side is slightly more complicated, and since here we have this, let's say, super sharp corner, this might need some tweaks to make it nice and smooth model. But as a first thing, we can try to make a loft here and see if we can achieve some good results for outer boundary here. Okay, so average, this looks good enough. I'm going to skip this bulge right now here. Probably it's difficult for me to understand if this is just a scanning defect or this part itself has had some dent in two places and really unstable edge. But let's try to go this way. Okay, so what we can do on this side, but before I'm continuing, I want to unhide my thickened surface to see if I have complete intersection everywhere, and I can see this sweep actually should be extended slightly. So in order to do that, let's edit our sketch and pull it slightly longer to the bottom side. Okay, now we're good to go. And after I have confirmed this sweep is long enough to intersect my solid body, I can hide my solid body and come over to this place to create some loft. And let's say I want it to be tangent and tangent, and this might give me actually a pretty good result here. Maybe I want to create this transition slightly sharper, but in general this is like super tiny feature. Of course we can extend slightly sweeps here to make it sharper, but for general use this should be just fine. So what we are going on this side to do, I'll hide my sketch, and I want to extend the sweep slightly longer, and I want to extend this one as well to intersect them. Okay, like this, so I can trim them. Okay, this looks good, so let's see, where's my solid? Okay, so in order to trim the solid, I would need to, again, extend this end here, like this, and on the opposite side as well. Okay, good. And now I have to figure out if I want to trim the solid now independently and then create this extra mounting surface of it and combine all that together, or to start with recreating these extra surfaces here and do the trim later. Probably I can trim it later, but before I'm going there, I don't completely like how this misfit looks here, so probably I want to go and edit my freeform surface. Let's see where I had it. Freeform copy. Okay, so in order to repair that one, I'm just going to pull this edge slightly like this. Probably this vertex also. Oh, maybe some of these as well. Okay, so now it's matching much better here. And should be good. Okay, so at this point I can continue with this tab here. So at this moment I want to bring back my main body here. And based on it, I will create cross-section sketch here. Something like this should work fine. And now I want to fit here a couple entities to create sketch for extrusion. This looks slightly more complicated because we don't have really nice scan data here, so it's a little bit junky. So we can go slightly freeform. Okay, so this one doesn't fit also, so I'm just going to create another tangent arc that could bend over close enough to my cross-section sketch. So slice point. Okay, let's disable clip, and so probably I'm going to fit here another straight line. and another tangent arc to sort of imitate this small tab, so we have more meat where to fasten this part with a bolt. And at this point, I'm just going to extend it further, same as on this side, I think. And I am just going to roughly close it off, hit and extrude. So I want to bring back my main body and I want to snap one side to it. And top side of extrusion, I'm just going to snap onto mesh somewhere here. Let's accept this. Okay, at the moment looks good enough, so let's unhide our thicken surface. And my trimming surface. So now I want to create trimming surfaces that would cut this solid as well. So let's just hide some solids and try to understand how we can achieve this. So in this case, this edge might be pretty much straightforward. So we can simply create here, most likely even just a straight line. And it should be good enough for this case. Okay, so again, let's repeat plain along path. Over, for example, here, let's create a cross section. It's an entity here. Extend it, accept, hide plane, and create a sweep. Okay, so this looks good enough. Probably in this case I can simply extend it straight away from sweep window. Make sure it's intersecting completely. This looks good. Okay, so in this case I can see that I have to extend this edge of sweep slightly. Like this. And probably I want to extend it this direction. Maybe not yet. It should be good on that side. And if we take a look on this side, this one will work fine as well. And the reason for this is because I'm simply going to trim them slightly different way. So first of all, what I want to do here, I want to duplicate this face and trim this solid with this duplicated face like this. Okay. Yep. Something failed here. Let's take a look. Okay. So basically I have to get rid of main surface. Okay, it indicates it's a single surface right now, so got it. So problem is I need to extend, oops, wrong button. So let's get rid of this trim here and try to extend this edge so it completely intersects my solid. Okay, solid body, good. Well, now I want to combine these two solids into one. Bring back my trimming surfaces. Probably I want to trim these two before proceeding further to make my workflow easier. And now I can trim my solids. No, not yet. So basically I need one more face here to complete this operation in correct way. And in order to do that, I'm going to construct plane from selected cut face. And at this point, I can try to create will this work or no? Oh, let's go a different way. Let's try to trim this solid with plane. This might be slightly problematic. Oh, seems it works. It indicates it's a solid body, so let's try to accept. Okay, it worked fine. And in this case, I can see that I actually probably it will be fine. So let's try to trim it and see what's the result. Okay, like this. Let's accept. Okay, it looks good enough here. And it looks good enough on this side as well. So now we could proceed with some fillets here and there, but before I'm doing that, I want to actually understand if I need this more flat edge here or not. And how can I actually deal with this? Of course, we can see that this edge most likely would be part of surfaces that I should create here in order to replicate completely this part. But good question is, do we actually need this in case of this part or no? Basically, we can try and see how it goes just to get closer to actual deviation here. Okay, so in order to do that, I'm going to create probably another 3D curve somewhere along this surface here. Let's just make it slightly smoother. So something like this. Let's create another plane along path somewhere where we can see nicely our scan data, somewhere here, for example. Let's enable clipping. And let's fit just a straight line like this. Okay, so let's perform sweep. And here we can see it looks quite good. Maybe something slightly off on this side, but again, questionable quality of this scan data. And if I should align to this super small deviation here, so probably not. Probably I will keep it as it is. Let's just flip it. So at this point, I would like to create here another surface. I think I will go absolutely the same way as I did it previously. So let's create another 3D curve. Let's make it slightly smoother like this. Construct another plane along path. Somewhere closer to the middle of it. This. Let's see. I will just slightly eyeball this for now and see what result can I achieve with this. Okay, so this one looks pretty good as well. Let's accept it. At this point, I would like to try to extend it and see how it goes. Same as I want to extend this side here as well. Okay, let's take a look at deviation analysis. Okay, cool. So we're very close everywhere here. I'm just going to extend this side slightly as well. Same as this one, so it completely intersects my solid. Oh, let's take a look. Okay, so at this moment I can see that probably I want to extend this edge as well. Okay, like this, so I have nice intersection here. Okay, so this is good so far. Let's trim these two together. Okay. Probably before this trim, I should extend this side edge as well. And repeat trimming here. Okay, looks good so far. Let's bring back my scan data here to try to figure out how can I blend this sharp corner on this side. So let's try to figure out some solution for this. Probably I can maybe use this face and create a loft between them. And in order to do that, I would need to trim this surface somewhere, say here. Project this sketch, get rid of these two. like this. Okay. And let's try to create here a loft. First, I don't need it that huge. Let's say probably at this moment I want to unlock the tangency weights to play with them individually here. This doesn't look like a great result, so let's cancel that plan and try to figure out different solutions. So probably I can create 3D curve somewhere here. Like this. Let's try to create loft once again from this one to this one. And use this 3D curve as a guide curve. Okay, not really result expected to see here. But in general, probably I can simply go and create another plane somewhere here. Simply eyeball this line for now because I'm not aiming here for some super precision. And let's try to do a sweep. See how it looks. Okay, it's not bad, not terrible. And we can align this side quite good here. Let's see what happens on the other side. Actually, we can work with this one, I think. Okay, so let's accept this one. Stand this edge. Stand it in opposite direction as well. Okay, and now I want to hide my solid to see how this corner would look like. Oh yeah, so here we can see it's quite unstable. But this is not really a solution I would like to see here. So that means I have to figure out some different solution for this case. Let's get rid of this one. Separate these two, get rid of that one. So probably I'm going to extend this edge slightly further and try to trim it. Okay, like this. And from here, actually, I'll try to create smooth 3D curve. Something like this. Okay. And I'm going to create another 3D curve somewhere here. Third one somewhere here. Okay, so select this one and this face, say project sketch here. This face and the 3D curve project sketch. Let's project this one as well. This, so now I can select three faces. To get rid of them. So something like this, and in this moment, probably fill surface could do the trick here. Okay. Let's see. Well, probably I should create my first curve slightly closer to edge here. But again, it's a good question. How we would like to proceed there. Of course, maybe I could have just created, let's take a look if I use here a new freeform. Something like this. Let's extend it. Disable snapping. Move this edge. Okay, let's try to unhide my solid here. Okay, so probably this might be even a better approach in this case. So let's get rid of a couple previous operations here. I don't need any of these 3D curves as well. And yeah, but here again we have this problem of not so nice and smooth edge. Of course, we can try to adapt our freeform surface slightly. Okay, so it will be something like this. And let's simply trim these two. Okay, so in this case, I'm much closer to deviation, and Well, this edge, I'm not completely satisfied. Of course, I could spend some slightly more time here to make it nicer and smoother transitions, but just for saving time, I'm going to skip this part right now. And see the overall result of our small project here. Of course, at this point we can come over to add some fillets here and there where it will be slightly logical to see them. Okay, for example, these, let's add some here to give it more finished look. Like this. So probably I want to add some fillet here as well. Okay, at this point, since this part has some sharp edges, I can't go with too huge fillet here. Something like super small might work fine. Here we can see this final result. Of course, we still have some small features here as this tab and this indent here, but for now I'm just going to skip them. So this was like general demonstration how we can deal with main surfaces, how we can construct trimming surfaces and things like that. So all these small features that are left here are just like prismatic parts, and it's quite simple to reverse engineer them. But still, if you have some questions and you struggle with this task, we can take a look at this further. Just let us know, probably in the comments, or you can write us an email and we will figure out this. So thanks for watching and see you next time.